Okay, this is section 8.1, which is a brief introduction to the structure of the atom. We'll get more into detail in future sections. Really, this section, all it does is it talks about a relatively famous experiment in physics, which provided us with some information about the structure of the atom. So let's take a look. I'm going to bring up a couple of photos, a couple of images for you to take a look at. Okay, so the question is, what's the structure of the atom? And we'll get more into detail of that. The famous experiment is called the Rutherford gold foil experiment. So what Rutherford did, his laboratory, was they took a material which had a radioactive source. So we'll talk more about what this source is. They're called alpha particles. Every once in a while, a particle moving at very high speed with positive electrical charge would fly in a straight line out of this source. And he had in the path of these particles a very, very thin piece of gold foil. Gold is an amazing material. You can make it ridiculously thin just by flattening it out. Only I think like 20 or 30 atoms thick, and it doesn't break if you're very careful with it. Most materials, if they're that thin, they'll break and they shatter into pieces. So these alpha particles would move through the gold foil, and what Rutherford's laboratory figured out, what the group figured out, was that most of the particles, surprisingly, just went straight through the gold and then hit a detector on the other side. So this is like representing film. They didn't have iPhones back then, so they used photographic film. And so what they would find is they would get some bright spots over here. And essentially what happened was the particles just went through the atoms as if the atoms weren't there. And the conclusion from that is that there was just nothing for them to collide with. So the vast majority of these alpha particles did not come into contact with anything, which means that most of the space of those gold atoms is pretty much empty, nothing to interact with. However, on occasion, one of these particles would bounce off at a ridiculously high angle. So instead of going straight through or moving off at a little bit of an angle, they would go off at very extreme angles. Okay, so like this generally didn't happen, but this is kind of suggesting that one went backwards, right? So this one like hit something really hard and then went backwards. This one over here moved off at an extreme angle. Now, in reality, the angles weren't that extreme, but they were, largely, most of them go straight through, and then some of them would deflect off at pretty good sized angles. So their conclusion from that, and it's our conclusion today, is that the atom itself is mostly space. These gold atoms are mostly empty space, but every once in a while, one of those alpha particles would hit something that's so hard, it would make the alpha particle bounce back in the opposite direction. And so here are two ways to kind of think about this. These were the two competing theories of the structure of the atom at the time. Now, they knew that atoms had electrons because electrons could be studied through essentially building television sets. And so they knew that there were these negatively charged particles called electrons. So what one theory said was that the atom, so imagine this is one gold atom, okay? The gold atom is essentially a big ball with positive charge kind of spread out evenly, like a sheet on a bed. There's positive charge everywhere on the bedspread, right, on the blanket. But that we know atoms are neutral, so if they have positive charge, they also have to have a negative charge, and that would be the electrons. So he said that the electrons were like these little particles in the positive charge. And so if you had enough of these negatively charged electrons, the cumulative negative charge, all that total negative charge would balance out the positive charge of this sheet of, this very thin sheet of positive charge. So the issue with that is that if you did send these alpha particles in, what you would expect is that they would come through the positive charge. They'd be, the alpha particles are positive themselves, so they'd be repelled by the positive. But it's not a lot of positive charge, right? The positive charge is distributed over a large area or a large volume. So they would kind of like interact with the positive charge and then maybe deflect off at small angles, right? So, slow them down and they'd move off like this. But that's not what they found. What they found was that almost all of them went straight through, but every once in a while, one would bounce backwards. So see, this is the Rutherford model. So his model, the Rutherford model, which is essentially what we use today, it's called the nuclear model. So here's our key finding. The atom is mostly empty space with a dense nucleus at the center and diffuse electrons around the nucleus. So you've got a nucleus at the center. It's mostly empty space, mostly nothing around here. And this is not exaggerated. This is actually under-exaggerated. The amount of space we're talking about relative to the size of the nucleus is enormous. It would be like if you had like a little golf ball and then put that in an entire stadium. The empty space that would be enormous for the atom. And then you have these negatively charged electrons kind of distributed around that one little nucleus. Okay, so here's the little blue ones are the electrons. The red would be called our nucleus. This is called the Rutherford model. We generally call it the nuclear model, meaning nucleus. Just like in biology, a cell generally has a nucleus at the center or near the center anyways. So again, the key findings, if you have this positive charge concentrated in this area here, it's going to be very heavy and very hard and positively charged. It's going to have a lot of positive charge because all the positive charge is in that little piece. So every once in a while, not very often, but every once in a while, the alpha particle will interact with this positive charge, be repulsed by it, right? Repelled and bounce back at an opposite angle. However, most of the alpha particles are just going through empty space, right? Because there is, the nucleus only takes up a little bit of space in the entire atom, okay? So that's our introduction. In the next section, what we'll do is we'll look at a little more detail of the structure of the nucleus. We'll look at protons and neutrons, and then that will lead us into radioactivity.